I have to assign someone to ask me every 10 minutes. Please.
5 points.
Okay, fine.
Yes, Ali.
Is it on now?
Yes, it is. So 300 minus 3x squared divided by 4. Obviously, this will change into 1200 minus 3x squared divided by 4. No critical numbers will come from v prime being undefined, but critical numbers will come from v prime being 0. So then 1200 minus 3x squared equals 0. Any questions? Please stop me anytime if there is something. You may see something and I don't. Yes, please.
I have to differentiate from 1200 minus 3. Wouldn't it be minus 9x? Or am I missing something?
So when I differentiate this, I get 300. Is that okay?
Yeah.
Is that where I should be looking?
No, next to it.
So I bring down 3, I subtract 1 from the power, and 4 is 4.
I'm talking like where you got the 1200 from.
Okay, I have to find the least common denominator, which is 4. I have to multiply this by 4. 300 times 4 is 1200 minus 3x squared over 4. I cannot solve the equation before. That's fine. So then negative 3x squared equals 1200 with minus in front. And then x squared equals 400. This is really nice.
It'd be negative 400.
But can I take the square root from negative 400? No. So I divide both sides by negative 3. And I get x squared equals 400. And now I'm in business. And I get x equals plus or minus 20. And you should say not so fast, because you cannot have negative centimeters. So it has to be the positive. And I'm asking you now, is this done? And you have to say no. Because there is no guarantee that x equals 20 and h. I have to find age as well. And age 300 over 20 minus 20 over 4. So this is 15 minus 5, so this is 10. So there is no guarantee that x equals 20 gives a maximum volume. So what we need to do next is x, v prime of x, 0, 20, infinity. So at 20, v prime is 0. And now I have to study the sign left and right. So here's the derivative. I'm going to copy it here. So v prime equals 1200 minus 3x squared divided by 4. I'm ready to study the sign. I will plug in 0. When I plug in 0, I get 1200 over 4. What sign is that? Now let's say I plug in 100. 100 squared will be 10,000 times negative 3 will be negative 30,000 plus 1200 and over 4 sign. So there is guarantee that this gives a maximum. And I can determine the volume, the maximum volume, which will be 20 squared times 10. So 4,000 cubic centimeters. If the problem is asking us, you don't have to determine it, but if it's asking us, yes. Any questions? Any questions? Okay. Number 19. Find the point on the line that is closest to the origin. Find the point on the line that is closest to the origin. First, I would like to find or graph this function. When x is 0, how much is y?
3.
So 0, 3, perfect. And when y is 0, how much is x?
Negative.
3 over 2. Very good. Negative 1.5, negative 1.5, comma 0. Let's graph it. So this is the graph of y equals 2x plus 3. Okay. I'm going to say that a point somewhere on this line is the closest to the origin. I'm going to say, I know you're going to disagree with me, and I will disagree with myself as well. I'm going to say it is this point that is the closest to the origin. Of course it's not, but I don't care where it is. This point has coordinates x comma y. Now I have to find a distance. I shouldn't be calling it distance d. I'm going to call it f of x. And what am I asked to find in this problem? The shortest distance, which means in terms of minimum, right? So we want to find min of f of x. But I have to find the function first. I have to have a function that gives the distance between a and the origin, and then I will find the minimum. That will, from that point on, is not going to be hard. But I need to find a function that gives the distance between a and the origin. So I have 2 points. I have a point a of x comma y, literally a of x comma, no, it's on the line. If it is on the line, the y value must be, oh, very good. So literally my point A is x comma 2x plus 3 because it is on the line. And I have a second point which has coordinates 0, 0. I want to find the formula for the distance, a, o, which would be our function f of x. We do know a formula for the distance between 2 points. So the distance is the square root of x2 minus x1, everything squared, plus y2 minus y1, everything squared. So it doesn't matter which direction you want to go, into 0 minus x and 0 minus 2x plus 3. So this will be our function f of x, which is the square root of, let's do this together, 0 minus x squared, squared, plus 0 minus 2x plus 3 means negative 2x minus 3 squared. I can drop the negative because both of them are negative and I have to square anyway. Right? So when I square this, I can change that into positive. So this will be the square root of x squared plus, can anyone give us this binomial squared? First day of classes, Please do not give me two terms.
4x squared plus 12x plus 9.
Excellent. Thank you. Awesome. So 5x squared plus 12x plus 9. This is our function. What is this function again? It's the function that gives the distance between this point and any point on the line. Anywhere you want. It doesn't matter where. This function, the distance, is f of x. Okay. After all this work, I have the function. What will I do now?
Question.
Yes, please.
Yeah, what's the plus 2x plus 3?
So when I write y1 was y2 was 0. 0 minus this. But since I have to square it, everything is positive. So 0 minus 2x minus 3 squared is the same with negative 1 times 2x plus 3, everything squared. So negative 1 squared is positive, so I only have to square that.
You could just put x as x2 and 2x plus 3 is.
I could have reversed them, yes. I could have said 2x plus x minus 0 and 2x plus 3 minus 0. I should have started there. It would have been easier. Is that better, Nico? Okay. Good, so we have the function. Now what? Yes. F prime of x is 1 over 2, the square root of 5x squared plus 12x plus 9 times. I've seen it in your tests and work. You do this. That's wrong. Is that clear? Without parentheses, it's wrong. So please remember that. Okay, so now what do I do? Is this ever 0? Even if it is, it will be, we can try, but the distance cannot be, this is a function, a square root function. It represents the distance will not be 0 between any point on this line and the origin. Could never be 0. Okay, so then f prime is 0 when x is negative 12 over 10 and negative 6/5. Is this true? I don't know.
Well, it is on that side.
I don't know. I have not shown that this gives a maximum or a minimum yet.
No.
That's my point. I don't know. I know that the derivative is 0 when x is negative 6/5. I know that. But I don't know if this gives a maximum or a minimum. So that's why I have to write x, f prime of x, 0. I'm sorry, that's 0 cannot be there. So negative 6/5 and 0, and let's say negative infinity and infinity. And 0 under negative 6/5. And now I have to study the sign of the first derivative. Is there a point of studying the sign of this quantity? No point. It's the square root. 2 in front, this will always be positive. Forget about it when it comes to the sign. Now I want to plug in 0. What do I get?
Positive.
Now I want to plug in negative 10. Now this is guaranteed that f of negative 6/5 will be so now I can go back to my graph and say for sure. So what is negative 6/5? Is negative 1.2, right? So x equals negative 6/5. If x of the point is negative 6/5, what is the y of the point? The y of the point will be 2 times negative 6/5 and plus 3. So that will be what? Negative 12 over 5 plus 3. 15, right? 15 minus, so it's 3/5. So the point A that will be at the minimum possible distance from the origin will have coordinates negative 6/5 and 3/5, negative 1.2 and 0.6. So here it is. So this was negative, shoot. Okay. I positioned it at negative 0.5 instead of positioning it at negative 1.5. It doesn't matter. But
You
it's,
could always just put a thing in right between the two.
no, I just wanted to have the correct graph. Sorry about that. I will use the same point. It doesn't matter which point you use. You will still find the one which is closest. So that's my point. That I just positioned at negative 0.5 instead of negative 1.5. Okay, so now where is the true point? Is one more time at negative 1.2 and 0.6. So this is the shortest possible distance from any point to the on this line to the origin. So the coordinates negative 1.2 comma 0.6 right here. So one more time, find the point on the line y equals 2x plus 3 that is closest to the origin. And the point is negative 1.2 comma 0.6. Yes. Any questions? Any questions? I hope you find the optimization interesting. It's not all of them are just very straightforward, however. Okay. Can we move on to another problem, or you would like to go back to another graph now? And then we can come back to more word problems. Another problem? Another problem. Very good. Uh, 33 on page 333. Let's take a look. The top and bottom margins of a poster area, oh no, I'm sorry, of a poster are each 6 centimeters and the side margins are each 4. So top and bottom 6 and side margin each 4, okay? Okay, that's what I know so far. If the area of the printed material on the poster is fixed at 384 square centimeters, find the dimensions of the poster with the smallest area. Or maybe, I don't know, maybe better is to denote this by y and this by x. We'll see in a minute. So let's read the problem one more time. So let's read it one more time. We'll go back. We'll go back. We'll go back. The top and bottom margins of a poster are each 6 centimeters. Oh,
Oh.
centimeters, not inches.
Yeah.
Sorry, I'm still upset about that. And the side margins are each 4 centimeters. If the area of the printed material on the poster is fixed at 384, find the dimensions of the poster with the smallest area.
Oh, so is the area of the whole thing 380?
The printed area. Oh, what we are, yes, we are interested
So the
in.
whole area is 384. You're just
No, the printed area.
The inner strip?
because 4 by 6. The area amount is 24.
The top and bottom margins of a poster
Alright.
are 6 and the side margins are 4. If the area of the printed material on the poster is fixed at 384 square centimeters, find the dimensions of the poster with the smallest area. I'm sorry? Paul, say it again.
I was saying that they're printing inside the margin. So. Yeah, it's
So the printed area is this, and the poster has a not uniform, but uniform sides and
I was thinking that it was 4 by 6. Ah, okay.
so it's like a framed picture. So this is the frame, and this is the picture.
Yep.
Okay, so we want to know what dimensions x and y, if that's how we want to go that route, if we want to go that route, or x, y here, we'll see in a minute, will minimize the total area. So let's start with the total area. We're trying to minimize the total area. One option would be, let's look at both options and then decide. One option would be, which I think is better, is to say that the area is x plus 8 multiplied by y plus 12. And not denote this by y and this by x, but denote the printed region, length, width x and height, or length and width, whatever you want to call it, it doesn't matter. So x times y. Where can anyone explain where the 8 and
Adding up the 2 6s and the other margins.
I see. Yeah.
right?
I see.
We also know that x times y, so let's go that route. No other option here. So x times y is definitely very good. So now the area I will distribute is xy plus 12x plus 8y plus 96.
Couldn't you do the other way? Would be just x minus 8 and y minus 12.
That's fine too. You can. You'll get the same thing. Okay. So obviously this will be replaced, xy will be replaced by this. And of course I have to get rid of one of the variables. So from here I will solve the equation for y, 384 divided by x. So now the area becomes a function of x indeed. 384 plus 96, how much is that? Is it 480? I got 480. You tell me if it's correct. Plus 12x plus 8 times 384 over x. Is it 30372?
Yes.
Thank you. Okay. Any questions on how we created the area of the entire poster? Any questions? Is it clear? Yes, Paul, please.
Just make sure I understand. So the first part, the x plus 8 left the 12, that's the inside?
The x plus 8?
Yeah.
X plus 8 is this.
Okay.
We are maximizing or minimizing the total area. So this is x plus 8. And this is y plus 12.
Okay. And then you also use x, y, which is normal area.
I have to distribute here, and I get this, and x times y. X times y is given to us as being 384.
Okay.
X times y is given 384. So when I distribute here, one of the terms is xy, so I'm going to replace it right away. And the other one is the y that needs to go away. So I solved this for y. And I replaced it in here. Is everyone okay with that? Okay. So this is our area. Now we want to find a prime, which is 12 minus 3072 over x squared. I have to find the least common denominator, which is 12x squared, which is x squared. So it's 12x squared minus 3072 over x squared. Now I'm looking for critical numbers. Perfect. So this function is undefined at 0, but 0 cannot be a critical number. Impossible, right? Because x can never not be 0. Good. So the only chance for critical numbers is from f prime being 0, which is 12x squared minus 3072 equals 0, or x squared equals 3072 over 12, whatever that is. Do we have a number? 3072 divided by 12. I got 256. That's really nice. And 256, the square root is plus or minus. So x equals 16, and everything was given in centimeters, aka inches. No, I'm kidding. Okay, so now we have no idea. We can be certain that this will give what? We're looking for, the problem was asking us to find the dimensions of the poster with the smallest area. So we cannot guarantee that this will give a minimum. We don't have any clue. So let's go back. So here is a prime.
Should we figure out y first?
I'm sorry?
Should we figure out what y is first?
We can, but let's make sure that this is, yes, but you're right, we can. The order is not important. We can find y and then show that it's a minimum. If it is, let's see. So I plug in 0. I can't, I'm sorry. Let's plug in 1. 1, it's 12 minus this, negative indeed. Now let's plug in 100. 12 times 100 squared, which is 10,000. Is this typical for and guaranteed for a minimum? Yes, it is. So then we know that x equals 16 centimeters, and now y will be 384 divided by 16. 384 divided by 16, and I get 24 centimeters. So the poster, careful, this is the inside. So this is x inside, so I have to add 8 to it. So what will be this? The width of the poster, 24 centimeters. And then the height, here I have to add 12 to y, and it's 36. So under the given conditions, the minimum possible poster that has that printed area and of 384 square centimeters, and it meets the requirements of 4, 4 left and right, and 6, 6 bottom and top. Has to have 24 centimeters in width and 36 centimeters in height. Any questions? Do we continue with more problems, or we want to go to a graph, or we want to look at the last section, which is Newton's method, that will help us solve any, and this is the last section of this chapter for this test,
Solve any one.
any equation on the planet with any accuracy you decide. 16 digits, 16 digits. Okay? And then we'll come back to it with more problems from both. Okay, last section, 4.9. No, it's 4.8. 4.9 is in this chapter, but I will connect it to chapter 5 because that is where it belongs. Newton's method. Okay. I hope you're working on the checklist. You are, right?